So to continue our discussion with regards to the soil physical properties, we have your soil water. Now, your soil water is important for the growth and development of your plants because it is the one responsible in carrying the ions and the solids to the roots of your plants where those nutrients can be absorbed. Now, the force that must be overcome by the plant roots to draw water from the soil is what we call your soil moisture retention. Now, your soil moisture moves from a zone of low tension to a zone of high tension, which means that from wetter soils, um, soil moisture retention is low in wet soils and it increases as the soil dries up. Now, the movement of your water goes from a wet soil to the dry soil. Now, again, your soil moisture retention is the force by which water is held in your soil and it must be overcome by your plants. Now, what is the importance of soil water? Your soil water again, it ensures that plants get enough water for processes like photosynthesis and nutrient absorption because your plants cannot photosynthesize without the presence of your water. Similarly, nutrient absorption is low or is impaired with low presence of soil water. Now, while preventing overwatering can harm the crops and waste our resources, it is vitally important to monitor your soil moisture because it helps predict natural disasters like floods and droughts. Now, in terms of soil moisture, it can be computed or it can be quantified by the two methods. You have your gravimetric method, which talks about the moisture content by mass or the weight of your water as compared to the weight of the soil from which it is contained. And you have your volumetric method. Now, volumetric method it refers to the volume of water occupied, volume occupied by the water compared to the total bulk volume of your uh, soil, including the pore spaces. Now, gravimetric method rather is computed by taking into account the amount of moisture divided by the oven dry weight. Now, what do we mean by the amount of moisture? Fresh weight minus oven dry weight is your water. Water divided by oven dry weight. What do we mean by oven dry weight? Oven dry weight is the mass of your soil without water. So fresh weight minus oven dry weight is the water divided by oven dry weight and you multiply it by 100 since naka-percent man siya. If decimal, then wag nang i-divide to 100. Now, since your volumetric method takes into account the bulk volume or the total volume, which includes the pore spaces. That's the reason why it is the bulk density that is used in the formula and not your particle density since we're taking into account the pore spaces. Okay, so let's have an example with regards to gravimetric and volumetric method. Okay, so in the problem, a cube of soil measures 10 by 10 by 10 centimeter and the total wet our total mass of 1,460 grams. Okay. So see 1,460 grams, which total weight, so that is the fresh weight, of which is 260 grams is water. So that is your water. Determine the volumetric water content and your bulk density. Now, how do we approach this problem? Okay, so we write the given. So we have given values. So the cube measures 10 by 10 by 10 centimeters. So 10 by 10 by 10 centimeters. Fresh weight is 1460. Water is 260. Determine the volumetric water content and your bulk density. Now, for the volumetric water content formula, it requires the moisture content by weight and your bulk density. So, first we have to solve for your bulk density. So, how to solve the bulk density? Remember the formula for bulk density is equal to proven dry weight over total volume of your soil or the bulk volume. Now, oven dry weight is just equal to the fresh weight minus the water. Okay, oven dry weight plus water is fresh weight. So, oven dry weight, you just magbawas ka lang or bawasan lang na ang tubig ang fresh weight. Kaya payment siyang tubig. So, fresh weight minus water. Ah, so, fresh weight minus water over your to get the bulk volumes, di yun naman sa problem na cube. Now, cube, the, the dimensions or to get the volume of the cube is you just multiply the size. So, 10 by 10 by 10 centimeters. So, just copy the formula. So, fresh weight minus water is 1460 minus 260 divided by 10 by 10 by 10. So 1,460 minus 260 is 1,200 grams. 10 times 10 times 10 is 1,000 cubic centimeter, which is equal to 1.2 grams per cubic centimeter. So, muna ay mukhang bulk density. So, okay na ka sa bulk density. To get the volumetric content, we need the moisture content by water, and you have to multiply it by bulk density. Okay, so moisture content by water using the formula fresh weight minus oven dry weight divided by oven dry weight. So, moisture content by water is fresh weight minus oven dry weight over oven dry weight times 100. So, ang fresh weight or ang pagbukaton sa imong soil, kuhaan nimo oven dry weight or soil lang is equal to just your water, amount of water divided by the oven dry weight. Pabalo naman ka sa amount of water times 100. So, ang amount of water is 260 grams. Kaya ang fresh weight nato is 1,460. Ang oven dry weight, yun, bawas lang nato o 260 ang fresh weight. So, water is just equal to 260 grams. So, kung sa kadaghanan ang tubig nga naan, divided by your oven dry weight. Asa gikan ang 1,200, again, dili na siya gikan. 1,460 minus 260 sa oven dry weight. Okay, kuhaan mo o tubig ang imong fresh weight times 100 is equal to 260 minus 1,260, 260 1,200 rather 0.2167 or 21.67% sa moisture content by water. Pero ang pamayo sa problem ay volumetric water content. Now, to get the volumetric water content is just equal to percent MCW times your bulk density. So, volumetric water content, atong gamiton ang dami ang decimal. So, that is your 0.2167, 0.2167 times your bulk density nga 1.2 na solve kanina. So, is equal to 0.2167 times bulk density 1.2, 0.26. Wait. But may percent man din dapat gamiton. So, naka times 100 na ni sila. Ibalik. So, that is your 21.67% times 1.2 is 26% or 0.26. So, muna niya ito ang final answer sa inyong moisture content by volumetric water content. So, say pasabutan ng 26%. Ibig sabihin daw, ang amount of water present in the soil is 26% by volume. Now, by volume, including man dato inyong volume of air, volume of water, and volume of soil. Now, in terms of moisture content by weight, ang ginafak ng magudana kay weight of the soil particles and weight of water kaya may weight of air. So, that's why mas dako ang moisture content by volume. Ay medyo mas dako ang value ang inyong moisture content by volume kontra sa inyong moisture content by mass or weight. Okay, so next problem. Determine the moisture content by weight per soil with a fresh weight of 40 grams and an oven-dried weight of 30 grams. So, yun sa problem is your moisture content by weight. Now, moisture content by weight is kaninang formula. So, just substitute moisture content by weight is equal to fresh weight minus super kapal ng pen. Just equal to fresh weight minus oven dry weight over oven dry weight times 100. So, ang fresh weight na nimo kay 40 grams. 40 grams minus 30 grams over 30 grams times 100. So, we have 40 minus 30 is 10. 10 divided by 30 is 0.33 times 100 is 33.33. So that's your moisture content by weight. Okay, so, ibig sabihin, 33.33%. So, yung sample nimo contains your water. Okay, last, determine the bulk density and measure content, gravimetric and volumetric method for the soil sample with a fresh weight of 50 grams placed in a 20 cubic centimeter container after oven drying the soil weight 40 grams. Okay, so for the bulk density, Kailangan na to ang kaning mga formula. Ipangayo man gravimetric and volumetric. Gravimetric is by weight, volumetric and by volume. So, atong values kay fresh weight of 50 grams, total volume is 20 cubic centimeter, oven dry weight is your 40 grams. Okay, so for the bulk density, you have mass of soil per volume or volume total. So that is any oven dried weight of 40 grams divided by 20 cm cube. That is 2 grams per cubic centimeter. So that is your bulk density or BB. Now, for the moisture content by water, fresh weight minus oven dry weight over oven dry weight. So, moisture content by water, by weight rather, is equal to fresh weight minus oven dry weight over oven dry weight times. Don't worry, provided ang formula sa exact. Okay, so fresh weight is your fresh weight of 50 grams. So 50 grams times 40 grams, and then 40 grams is 100 is 50 minus 40 is 10 divided by 40. 25 times 100 is 25. So 0.24 25% moisture content by weight. So, okay na ta sa gravimetric method. Next is your volumetric method. For the volumetric method, measure content by weight, is both density. So simply multiply the values so far. So measure content by volume is 0.2%. Density water times bulk density is equal to 25% times N 2 grams per cubic is equal to 25 times 2. How about 2? 40 divided by 20 is 2. 10 divided by 40 times 125. 0.25 times 2.5, 50% or 0.075 volume. Okay. Next, we have the different. Next is you have the different tawag dito, different soil moisture characteristics. In terms of soil moisture characteristics sa field, natay upat ka scenario. You have a saturation at field capacity, between field capacity or the available water in your boiling point. Okay, so dito mo ko na si mo saturation. Kini sa aspect. Okay. So saturation, shown in the figure, pores are full of water, gravitational water is lost. Now, saturation in your soil happens after rainfall or an irrigation. So, during a rain or shower or irrigation application ka na mag-add mo water, the pore spaces in your soils are filled with water. Now, if all pores are filled with water, that's the time that your soil is said to be in saturation, wherein wala na air left para sa imuhang pore spaces. All soil water ang nag-occupy. So, ang illustration ana kahit kanang magtulo-tulo na or puno na gid kayo og tubig ang imuhang soil. Now, field capacity, the next portion, field capacity is uh, referred to the available water for plant growth nga imuhang water and soil contents are considered to be ideal. Imuhang water, full, saturated po siya, pero dili siya to the point na magtulo-tulo na imuhang water sa imuhang present sa imong soil. So, muna imong field capacity, we irrigate only up to field capacity. We don't irrigate up to as saturation. Okay, if saturation man good, na chances na mag-leach or mag-erode yung soil. Ang atong dapat lang gid ng buhaton kay mag-irrigate up to field capacity nga tama lang ang imuhang amount of water, not na over dripping na kay sa saturation too much water. Now, wilting point, kaning wilting point, nahitabo ni siya kapag ang soil na present, ang water na present sa inyong soil or the water stored in the soil is taken up by the plant roots, some of it is evaporated. Now, what happens na after irrigation or after a rain, syempre, ginagamit ng plants yung water. Now, through time, as time goes on, without introduction of water or without adding more water, your water is taken up by your plants, some of it is evaporated. There will come a time wherein the uptake of water is not sufficient to meet the needs of your plants. So there is not enough water present in your soil. So as you can see in the illustration, the blue color indicates your water, the white indicates your air. So there's more air now than the water present. Now at a certain stage, soil water content dies. I mean, the soil water content is not enough to support the life of your plant. So may soil water man na present pero dili na siya kaya waon sa imong plants. Dili niya kayang overcome ang tension. So that's the time that your plant dies. So that's what we call your permanent wilting point or your wilting point. Now, at this point, sa wilting point, the soil contains some water, pero again, it is difficult for your plants to get those water. So, reversible na. Once mag-reach ang imong plant to permanent wilting point, irreversible na siya. Halagin mo na siyang tubigan pa yung soil, dili na na mabuhi ang imong plants. So, in field capacity, that is the ideal. Wilting point is not the ideal. So, unsa may in between sa inyong field capacity and your wilting point. In between your field capacity and your wilting point, that's what we call your available water content. So that is field capacity minus your wilting point. Now, at available water content, it is the actual amount of water that is available for the plant. Na muna siya ang stored in between your field capacity and after field capacity, syempre ginagamit yung plants ang water sa mga it is evaporated. Now, in between ka time after ka magpatubig and katulong point that is your available water content. Again, saturation usually happens after irrigation, nga gabi ka, daghan, and the heavy rain. Field capacity, that's the time na wala na yung mag-rain ng water pero puno pagyapon of water ang imong soil. Wilting point is the point wherein The soil water is not enough to support the growth of your plants, the life of your plant, so your plant dies and wilts. And in between your field capacity and wilting point is your available water content. So soil water content, actual water, or available water rather, depends greatly on the soil texture and structure. Again, field capacity, permanent wilting point, and available water content are called your soil moisture characteristics. So these characteristics are constant for a given soil, but they vary widely from one type of soil to another. Okay, so this is an illustration of a crop during moderate drought in early growth stages. As you can see, may portion na dry pero they're still thriving, kaya pa may enough water. Kanina lagi ang mahitabo if mag-reach na og wilting point ang plants. So, observe leaf rolling in early growth stages and kapag sa late growth stages na sa imong plant tas sapay na kaning severe drought na gyud imong growth stages. Kanusa man day mag-dry kunyari sa rice, dry lang ang imong land only up to around 1 week before harvest or 2 weeks. Tapos if dry imong land earlier than that, then dili ni jud during the vegetative phase of your rice, dili mabuhi ang imong rice. Not unless your rice is a upland variety kung wala is studying water. Okay, so next property of your soil is your soil consistence. Now, soil consistence is the resistance of your soil to deformation or rupture. In other words, it refers to the behavior of soil when pressure is applied. So, when you take a soil sample, applyan mo pressure at various moisture content. So, ginadetermine din na if yung soil then wet ba siya, moist, or dry. Number soil consistence deals with the strength and nature of the forces between your soil particles. So it is very important in estimating the ability of your soil to support structures, mechanism mga constructions, mga buildings, labi ng mga three-story na galing ng mga building. Dahil dyan nga business ay anang building permit and tax. Or two-story pero na rooftop, kinahanglan na siya o soil na ang strength sa inyong lupa kung kaya ba niya mag-support sa structure. Okay. So in terms of soil consistence, first we have we have three terms. We have wet soil, moist soil, and dry soil. In terms of wet soil, when your soil is saturated, we look at two specific traits. You have the stickiness and your elasticity. Now, stickiness is how much the soil adheres to your fingers. So, unsa siya mupilit sa inyong fingers. So, it ranges from non-sticky, slightly sticky, sticky, and very sticky. So, kapag wet po ang inyong soil, pwede po siya in terms of its elasticity. Kung plasticity, it refers to how easily ang inyong soil mag-mold or ma-deform. So, ang pinaka-mold, so that is your very plastic soil. Ang dili jud ni mold na soil is non-plastic soil. Plastic soils have high clay content, non-plastic soils mas daghang sandy soils. Now, kapag moist naman ang imong soil, moist soil happens kapag there is enough water, there's a right balance of water and air in your soil. Now, moist soil is an important state rather for your farmers because it describes the conditions of soils when they are tilled in the field. Now, we measure moist soil in order of its coherence. So, pwede ka on the loose end, sa dili kayo easily mag-crumble or sa pinaka mag-crumble rather yung soil, you have your friable soil. So, friable soil is the ideal standard for planting. because dali man siya mag-crumble under gentle pressure. So very loose. Next is very friable, firm, and extremely firm. Now, extremely firm is on the tougher end, wherein dili na gyud ma-manipulate ani mo sila, di na siya kagahi. Ang ideal sa farming is your loose or very friable na soil. And lastly, you have your dry soil. Now, dry soil, it characterizes your soil in terms of its rigidity or brittleness. So, it ranges from loose, like sand, to soft, like silt, and then scales up to hard, very hard, and extremely hard. Now, if kailangan ka og martilyo para ma-break ang imong soil clad, that's the time you're dealing with an extremely hard consistence. Okay, so unsay practical application sa imong soil consistence? Imagine you have two soils. Now, imong isa ka soil is sticky and plastic. Now, your other soil is crumble and friable. So, sticky and plastic, and imong other soil kay, no, sticky and plastic, so wet soil, and your other soil is crumbly and friable. Now, ang pangutana is, which is more suitable for agriculture? The one that is more suitable for agriculture is your crumbly and friable soil because friable soil allows superior growth manggod sa imong roots kay dali spread up ang imong roots sa imong plants. Imong sticky and plastic soil, although they hold better nutrients, dili mo siya dali i-work with. So it compacts easily and may tendency nga malumos niya imong roots when wet. So for a healthy crop, ang ideal is your crumbly and friable na soil consistency. Lastly, you have your soil color. Now, soil color is the most obvious, this easily determined property that we can assess right in the field. So, your soil color is used as an indicator, usually sa organic matter, sa drainage, sa state of aeration, and dati ginatawag na Munsell color chart. So, kani siya ang ginagamit as a form of comparison for your color. Okay, so in terms of soil color, manggod, we have three variables. You have the hue, value, and your chroma. Now, your hue is refers to the dominant wavelength sa imong soil color. So, sa ipasabot sa dominant wavelength. So, either red, yellow, purple red, purple blue green, green yellow, or yellow red. When you talk about the value, it refers to the darkness or lightness of your color. So, tendency niya kay white to black ang iyang intensity, kung light or dark color. And then chroma refers to the intensity or brightness or sa ka strong ang isa ka color niyo. So, sila, the various combination of hue, value, and chroma dictates the different soil colors using the Munsell color chart. Now, what is the practical application of your soil color? Now, black soils typically contains high organic matter, usually found in your horizons. So, it is characterized with slow drainage, with moderate waterlogging potential. Again, it is common in horizon, so common sa mga forest tops or mga peatlands. Your brown colors indicates moderate to high organic matter with combination of your mineral soil. So it is characterized to be well drained, so tama lang yapon yung aeration with low water logging potential kanong clogging ang inyong lupa. So it is usually found in your A horizon, so mixtures of mineral and organic matter. Now, yellow soils typically gives us an idea that probably your soil contains iron in hydrated form. So it indicates poor drainage with medium to low organic matter. So basta makita yung mga yellow colored soil, usually sa mga E-elevated zone, yung E horizon or your B horizon. So and lastly, kapag gray ang soil, asa mo na makita kasagara ang gray na soil? Gray na soil, makita na siya sa mga kanal, sa mga putikan. So, kung sa may makita ninyo sa mga, kasi may characteristics ng mga lupa sa pagkasalan ng tubig or sa mga kanal. So, gray soils usually indicates fairly constant saturation. So, fairly sila mabasa. Ibig sabihin, they have poor drainage. So, if gray mong soil, most likely, fairly na siya basa with poor drainage, with poor ang iyang aeration. So, glade grays at that zones, it is ideal for aquaculture rice rotation, pero kapag magtanom ka o mga vegetable crops, may soils are not ideal. Okay, so that's it for your physical soil properties.